Hello, everyone. Thank you for joining us today. My name is Brian Budzinski, Senior Managing Editor of Roads and Bridges Media. On behalf of Roads and Bridges Media and our sponsor, Aquajet, I would like to welcome you to today's presentation titled Wastewater Solutions for Hydrodemolition Road and Bridge Repairs. Robotic hydrodemolition is rising to the challenge of addressing the need for fast, safe, and efficient concrete removal for road and bridge repair applications. But it comes with an obvious question. What do you do with the wastewater? How contractors choose to collect, treat, and discharge of wastewater is crucial to a project's overall success and cost effectiveness. This webinar will explore how on-site, on-demand treatment systems from reputable original equipment manufacturers can provide safety and efficiency benefits over third-party vacuum services and other aftermarket alternatives, ensuring water independence and giving contractors the ability to recycle water, as well as meeting or exceeding even the strictest environmental restrictions for wastewater treatment. The webinar will also provide an overview of the hydrodemolition process and outline key technologies to consider for the safest, most productive water treatment options. Over the course of this presentation, our presenters will outline the overall benefits of hydrodemolition for bridge and road repair applications, discuss how hydrodemolition can be used for all bridge components, including bridge deck, piles, and parapets, compare several common wastewater treatment options, third-party vacuum services, aftermarket systems, and on-site OEM solutions, understand the importance of water independence and recycling for hydrodemolition applications in terms of budgets and environmental impact, and identify key technologies to optimize safety and efficiency with water treatment system selection. We're going to get started in just a couple of minutes, but first, a little housekeeping. You will notice on your viewer that you have the ability to ask questions. We encourage you to ask questions, and we'll try to answer as many as we can at the end of the presentation based on time availability. Any questions we do not get to, we will answer offline. Our presenters today are Keith Armishaw and Sean Kirkpatrick. Keith Armishaw is the Business Development Manager for Aquajet's North American subsidiary. Before joining Aquajet in 2019, Keith amassed 24 years of industry experience with the brand as a service technician, service manager, and sales associate through a Quebec-based distributor. He works closely with the regional sales team to grow awareness of Aquajet's solutions and enhance customer support with industry-wide education initiatives that increase understanding of the benefits of hydrodemolition. Sean Kirkpatrick is the Service and Application Specialist for Aquajet's North American subsidiary and for Brock Inc. He assists customers with service after the sale for both Aquajet hydrodemolition robots and Brock demolition machines. Sean has extensive experience with electrical repair and hydraulic theory, repair, and application training. I'll turn the presentation over to Keith and Sean.
Thank you, Brian.
Thanks, Brian.
People recognize, this will be my voice, Keith Armishaw. Sean?
And I'm Sean Kirkpatrick.
So we got a lot of things to talk about, not much time to do it, so let's get things rolling right now. So we'll give you a brief description of Aquajet and who we are. So we're the industry leader in hydrodemolition machines. We offer 6 hydrodemolition robots, high-pressure pumps, water treatment systems. We also have a wide range of accessories for our robots. Our machines make hydrodemolition easier and more cost-effective. Through Brock Inc., Aquajet has facilities and representation across North America to support customers with inventory of machines, parts, service, and training. We have location in New Jersey, Missouri, and Washington State. We're in an excellent position to help support our customers in their hydrodemolition business. So Aquajet's been manufacturing hydrodemolition equipment since 1988. So today we're here to talk about road and bridge structures. So the North American road and bridge need work. Out of nearly 617,000 U.S. bridges, almost 40% are 50 years or older. About 1/3 are in critical need of repair. A recent estimate lists the U.S. backlog of bridge rehabilitation needs in excess of $123 billion. Replacing every aging bridge is impractical, so owners, engineers, contractors need to find a cost-effective way to repair these infrastructures. So why not choose hydrodemolition to do some of that work? So, a few benefits of the hydrodemolition. It virtually eliminates silica dust by using water that will suppress the dust. No microfracturing, so we have no mechanical impact on the structure. Good bonding surface for new concrete overlay. Extended lifespan of the repair can be 3 times higher. Some studies showed that the life expectancy could be 21 to 35 years longer compared to 7 to 12 years using mechanical chiseling or mechanical removal method. We clean the rebar without damage. And also we increase worker safety by decreasing the risk of falls, decrease silica dust exposure we just mentioned, and no harmful vibration. Production rates can vary depending on the type of product, the type of concrete, positioning of the equipment, but in general around 1 to 1.5 cubic meters per hour of removal rate are reasonable values. So we want to take a look at now is just walk you through briefly what hydrodemolition can be used on many parts of a bridge. So a couple of examples we're going to take a look at here. So deck repair work. So we could be used, for example, partial removal, full depth removal. Could be removing the bridge expansion joint, exposing the rebar to tie in to the new joint or new structure. Again, here, this would be part of a next photo is concrete, removing concrete to expand the road, a highway, or expanding a bridge to add another lane. So we're freeing the rebar to tie into the new structure again. So hydrodemolition equipment is versatile. It can be used in not only on horizontal work, as we saw in the previous slide. It can also be used for vertical work. A few examples we can see here. On the left side is a circular power head, which is a device that lets the high pressure water jet travel all around the structure, so increasing efficiency and productivity without having to move the machine. In this image, we could see that the reach is up to 7 meters freestanding, without any additional support. In that photo, it's interesting because they were exposing the top 10 feet of the pillar to tie into a new structure that was going to be on this bridge. On the right-hand side, we can see a demolition robot being used on a pillar. So for concrete removal and repair, again, machine can go even over 7 meters or 23 feet with additional support. Maybe Sean, you'd like to handle this one?
Yeah, I like how this one, you can see how with the robot sitting up on top of it, on top of the bridge, there's an extension arm that can be mounted onto the to the beam of the robot. This is what the roller or the cutting head traverses across. And on both of the photographs, you see the arm with the elbow and then the cutting head down below. On the photograph on the left, you can see where it actually goes up underneath and is shooting back up towards the robot from the bottom side. So there's kits that can be added onto the robots, such as spines or frames, and these can be mounted onto a wall or up underneath a bridge to assist in the removal of the concrete or coating removal.
Thank you, Sean.
Sure.
So since we're talking of roads and bridges, we thought it important to include tunnel work, because tunnels are part of that, our roadway infrastructure. So hydrodemolition can be used and is used in a lot of tunnel work. It could be for wall removal, for demolition on the wall, or overhead, even in different shapes of the tunnel. We also have compact equipment that could fit through a 32-inch doorway. So for any utility tunnels where you need, where we have limited access to get tools and equipment in to demolish or repair concrete in these structures. There's compact equipment that exists that's able to perform that type of work. And you can see in this photo on the right-hand side, the machine inside a utility tunnel with all the equipment around there. Maybe Sean?
This is a shot from AK Services working up. They're out of the Boston area, and this is on I-95, Interstate 95, going from Massachusetts, from Maine into New Hampshire, across the Merrimack River. The job specifically here was they were removing the metal guardrail on the side. They want to replace it with concrete. So they had to cut out about 30 inches of concrete, about 7 inches deep, so they could tie into the existing rebar and then form it up to pour in the sidewall. And on this one, they used the existing drains in the bridge already, plugged off some of the drains, and then allowed the water to flow down to strategically placed drains that would drain down underneath of the bridge, where the water was captured into reservoirs. And then at night, they would take that water away and treat it at another location. So the containment was underneath of the bridge on this one for off-site treatment.
Yeah. Thank you, Sean. This is a different, another case study we have with customer, Neilco Builders. So this was a bridge deck rehabilitation in North Vancouver, British Columbia, Canada. Customer used the Aquacutter 710V hydrodemolition robot. You can see in the right-hand photo. We had to remove 5 to 6 inches of concrete to expose the rebar that had been set there 60 years before when the bridge was initially built. It had been repaired once about 40 years ago. You can see the removal chamfer created by the robot. That border had to be removed, so we basically was left there, cut into the structure a little bit, so it'd be easier to remove at the end of the project, and it was also to help channel the water.
And that's good there, where you can see the chamfer right into the curb mark, undercutting up into that, which was what they needed, right?
Yes, correct. So the water in this case would flow naturally to one corner of the bridge deck, and at that end it was collected and pumped into an on-site treatment system, which was composed of large tanks, CO2 treatment, and I guess it was had some chemical products to help settle the fines. An interesting aspect on this project was that the under the bridge was completely closed in to prevent any water leakage or blow-throughs, which may happen on different structures. And water was collected if it did go through, and treated also. So it was a nice setup by Neilco Builders.
This one is a patchwork that they did on a 17-mile long bridge, both sides of it, so both ways. So anytime you had to go from one side to the other, it was a 34-mile round trip to get back around to it if you forgot anything. This bridge here is near Breaux Bridge, Louisiana. It was done by Aggregate Technologies out of Houston, Texas. And the work that they were doing here was there's a lot of patchwork on the surface of the bridge where they had to do slight repairs, but it was only an inch, maybe 2 inches deep. They used 710V. And on this particular job, they would plug off the drains to the bridge so that it didn't drain down into the bayou down below, or the river. And then they would have a vacuum truck sitting, which is in the photograph right there, the headlights shining on the robot at night, that removed the debris and sucked up all the water. And then also that was shipped off of the bridge and then treated off-site.
Yeah, since this, Sean, maybe you can correct me if I'm wrong, but since this was a patchwork, using the vac truck to collect debris and water was a good solution.
Yes. Yeah, for how long the bridge was and how tight the job site was. And we were moving constantly too, so to be able to move the whole kit took quite a bit, even with just having the robot and the vacuum truck and the water tank there.
Yeah, and the high pressure pump system.
And the high pressure pump.
Okay, thank you. So, hydrodemolition addresses the need for fast, safe, and efficient concrete removal. But it comes with an obvious question. What do you do with the wastewater? The wastewater from blasting has an increased level of pH in the range of 10 to 13 and a high turbidity level, or a high value of suspended solids. The water has to be captured and treated. So what options are out there for you to treat your water? So I guess we could start with some options of off-site water treatment. So what's involved with off-site water treatment is basically the water is collected on site, as we demonstrated on a few of those projects previously, and needs to be hauled from the site to normally a third-party company or contractor who will dispose of the water appropriately. So he'll remove the fines from the water, treat the pH level, and then discharge it or send it back into a sewer system. So vacuum collection is good in some cases. If the project is a little longer and there's a lot more work to be done in the same location, might not be the ideal solution. Collecting and hauling services, no, it's not cheap. So service can run up to, we found variable numbers, but around 15 cents per gallon. And plus the hauling fees, the vehicle and personnel fees, so it can run you up to $50,000 for 1 week project. So it can be a costly operation. The other option we have is on-site, on-demand water treatment systems. This is interesting because there's several ways of looking at it. Some people design their own systems by using components like tanks, filters, weir tanks, chemical dosing stations, acid, CO2, all kinds of different components that are put together. Disadvantage of this is every job is unique, and now you're coming in with equipment that's not necessarily designed for the process in regards to flow and material handling. So often this system or setup is very bulky and requires a large footprint on a job site. And we all know that for being on many projects, that the available room or space on a project, especially on a bridge deck or on a highway, are very limited. So we don't always have the luxury of setting up tanks, multiple tanks, and filters and weir tanks to support the project. On-site water treatment built by manufacturers, for example, Aquajet builds a system. These units are often compact, easy to haul. They have a small job site footprint. The blast water can be treated whenever you want. So you're not coordinating with a contractor or a third-party company to come in and support you. There's no scheduling to be done there. Some of them can move as much as 88 gallons per minute, which is in most cases more than enough for hydrodemolition applications. And this water can be is treated, released, or it can even be reused in some cases. And the cost of doing this is typically very low compared to hauling. It's almost 25 times cheaper than hauling. Maybe Sean, you can cover this one, please.
Sure. The Aquajet approach is to provide a complete hydrodemolition solution, including water treatment. So what we've got here in this drawing is what we call the power pack, which is a high pressure pump. Needs to get water from somewhere. So we've got a reservoir start up in the upper left-hand corner there. That water is pumped into the power pack or high pressure pump, and then that is pumped to the robot. That's where the work's done. So the hydrodemolition is the lance on the robot does the work. Then that water goes downstream or downhill and is collected by what we usually just call a trash pump. The trash pump pumps the water into the water treatment system. Ours is the ECOCLEAR 20. That water is treated as it goes through it, and then is separated from the solids, which go into either a tote or 55-gallon drums or some containment like that. And then the cleaned water goes back into the reservoir, either directly back to be used in the robot, or if it's too warm, we do have a limitation of 40 degrees Celsius for most of our pumps for high temperature. So we can let that water cool in a larger reservoir, and then it can be pumped back into the power pack or high pressure pump to complete the circuit. Footprint is pretty small of this. The fairly low cost of operation because you're not getting rid of any water, you're not getting water off of it. We can treat up to more than 3,000 gallons per hour or 26,000 gallons per an 8-hour shift. That can save 20 to 25,000 gallons per day. It's like filling a pool every 2 hours.
Yep. Thank you, Sean.
Sure.
So what Sean was bringing up, this recycling is, we rely less on water, low cost of operation, and a small footprint physically, and a small footprint on the environment, small impact. We have some customers who've demonstrated that on a few projects. We're just going to walk through this briefly. So this is a quick case study done by that we did on a customer here. So Kias Hydroelectric Generation Station on the Lower Nelson River in Manitoba, Canada. They had an 8-foot pier damaged by frozen water in a 24-inch intake pipe. So this pipe froze and split the pier open. This was a fairly new structure. A customer water blasting and vacuum services removed a solid concrete pier 8 feet thick, 40 feet wide, and 30 feet tall at the highest point. They removed almost 5,000 cubic feet of concrete on this structure. They used an AquaJet AquaCutter 710V with tower system, and they also used our EcoClear, AquaJet's EcoClear water treatment system. They needed to ensure that no untreated water escaped into the environment. This was the demand, the request that they had from contractor on site. The water was hauled to fill the tank initially, and then once the hydrodemolition began, they relied on the EcoClear, the water treatment system, to reuse the water in the machine. So basically, they recycled 1.3 million gallons of water on this project, which lasted about 40 days. So that's an enormous amount of water to save on a project. And that ensured that they were efficient, not relying on water being supplied by a truck service or an unreliable source. And they were able to stay on time, on track, by having easy access to water and also lowering their footprint on the environmental footprint on this project, which 1.3 million gallons is a lot of water. Next up, we have a brief video. We'll just walk you through it briefly here. Maybe Sean, you can walk through it with the audience here.
Sure.
This is from one of our customer ADS out of Europe, but there's some good footage on here where you guys can see some stuff that help you understand a bit what's going on the project.
Yeah, it's a nice example of the full system. You can see the robot there. It's not typical that we have the lance completely exposed like that, but for this particular job, I guess they had to fit it in that curb. So you can see it removing the curb right there. And then down below there on the right is the ECOCLEAR and another couple components to store the water that either comes in or goes out to feed their high pressure pumps. There's the high pressure pumps in the trucks right there. And you see this is live traffic, and you can see how they're getting the job done there. There's the high pressure hose. There's the pump collecting the water, pumping it into the clear tank. There's the interior of the ECOCLEAR. You see the dosing pumps. These are what pumps the coagulant and flocculant into the machine. And there's the interior of it working. There's not a lot of moving parts of the ECOCLEAR. It's just two couple pumps to a couple of motors to stir the chemicals into it, and then there's the discharge water coming out clean. And you can typically get that water down to less than a total suspended solids of 50,000 parts per million. And it's also a robot with the arm added onto it.
Yeah.
You can really see it working there. I like specialty jobs like that.
Nice shot of the rebar exposed, ready to pour new concrete over it.
Good to go.
Yeah, thanks EDS for sharing this great video with us. Okay, let's move on now. Let's see. I guess this is interesting machine, Sean, so maybe you can walk us through on how this thing works, right?
Sure. So the water's collected by the pump that we pointed out in the last video. So that pump can be controlled by the ECOCLEAR. There's also an inlet valve. So the water's pumped into it. It monitors how much water's coming in and how dirty that water is, and also what the pH level of that water is. The water goes. Why
are we doing that though?
So we know how to treat it. And then in the first one, the inlet tank, we get the TSS, or the total suspended solids, measured, and then we also check the pH at that level. The most important thing is to adjust the pH to allow the flocculant and the coagulant, which are added in the first two tanks, to do their job. So once the coagulant and the flocculant, what they do is they clump the material together and make it heavy. So then it goes into the third tank, which is the settling tank, and you can see it like that one it's called the clarifier. It's shaped like a funnel, and down at the bottom of that there is a sludge pump, and that sludge pump either takes that water and the dirty sludge and puts it back in the first two tanks, or when it senses how dirty it is, it pumps it out into either a 55-gallon drum or a tote or something like that to dispose of. But as it's going through the clarifiers, it hits these lamellar panels, and as it's hitting these panels, it settles and drops out. And then what comes out over into the next one would be in tank 4. That's where the pH is double checked, and also the TSS is double checked. Make sure the water is okay. If we need a little bit of adjustment with the pH, we do it there. If the water is outside of the parameters, the machine will shut itself off. But all this information that is being collected is also recorded. So then as it's recorded, we can keep that information downloaded onto a USB stick and then print it out as either a Excel file.
Yeah.
For documentation.
Good. That's good. That's a very interesting process and very compact system also.
And one of the most important things I forgot to mention is it's automated. You don't have to sit here and make adjustments as it's going. It can see by the total suspended solids that or the pH of what it needs to do to that water to clean it up.
Okay, so you're telling me we don't need to have a chemist on site or a water treatment specialist? Good. Okay, let's move on then. Thanks, Sean.
Sure.
So water treatment systems are manufactured with a variety of features. Each affect the safety, efficiency, and profitability for different projects. Some things to consider when looking for solutions. I guess the size of the unit. So again, how compact is it? How big a footprint is available on your project? So typically you want to go as small as you can. In the case of the ECOCLEAR, we're talking about a 20-foot container, a standard ISO 20-foot container. High volume. Of course, we're speaking high volume not for dewatering projects, but high volume for hydrodemolition projects, which are typically between 50 to 100 gallons per minute. And our system can treat up to 88 gallons a minute. So considering the loss of water that happens during the process, we're good to cover at least 100 gallon per minute high pressure pump project with the ECOCLEAR.
Yeah, especially for the fact that it's not always 100% on. So a little bit of downtime. It always has a chance to catch up.
Yeah. Is the system automated? So if you're looking at a system, is it, will it run on its own, or do you have to have someone constantly monitoring it? What type of feedback do you get back from it? Any alarms? What's there to ensure that the quality of water is what you want it to be? So the ECOCLEAR has its own automated system, which you can see little drawing of the process here, which is very useful. And how are you going to monitor the water quality, I guess, is a big question. What can your equipment that you're bringing to site, what quality of water can it deliver? For example, the ECOCLEAR from Aquajet can deliver pH from 6 to 9, and we can reach turbidity levels down to 20 to 40 milligrams per liter.
And sometimes even better than that, which is great.
Yeah, of course, every project varies depending on the amount of cement fines that are collected in the project. So the equipment, typically you're looking for equipment that is self-contained. So I mean, I've been on sites where we've seen many third-party systems where they're coming in with 2 or 3 tanks, different containers, and end up with a huge footprint on site. This is, again, one 20-foot container. Most OEM systems would be self-contained, so everything would be in it. It simplifies the whole process. So it makes it cost-effective transport, requires less space on job. It's ready to use when you need it. This system, I mean, you just start pumping water into it, and once it's calibrated, you can shut it off or turn it on. It's not a problem. We figure generally it can be set up and up and running in within 4 hours. It can be operated by a single person and not even a full-time person. So that'll reduce labor needs. It has a fully functional hydraulic roof, gives way to collapsible access platform and walkway, allowing operator to monitor the various stages of the treatment, completing routine maintenance and conduct water sample testing if required. So Sean, maybe you can cover this one.
Yeah, sure. Many wastewater systems use mineral or citric acid to reduce the pH of the water, which comes with safety risks and high operating expenses. Instead, look for an option that uses CO2. Carbon dioxide is safe to handle. No special training, no special PPE required. Precision and control reduce the use of acid, can unintentionally acidify the water. Virtually impossible with CO2. No hazardous products with CO2, and it's 4 to 8 times cheaper, less expensive than other acids, or than acids.
Thank you. So another project that was performed that we'd like to, before closing, just to review, give you an little idea of what can be done or what some customers are doing with the equipment. So this case study is a project that was performed in Florenceville, New Brunswick, Canada. Basically, they had to demolish or do some hydrodemolition work on the sidewalk, pillars, and bridge supports. They needed a new access ramp to the bridge, so they basically took out the old section, and then they had to readjust things and components that they wanted to keep to tie into the old structure. The river was a source of water. It was a challenge because this was in the spring, so water from the river was the turbidity level was very high. So the customer was pumping that through his filter system before going into the high pressure pumps, and ended up being quite a challenge until he was able to fill his ECOCLEAR water treatment system that was able to basically deliver cleaner water than what was able to get out of the river at that time. So ECOCLEAR was used to treat the water on site and saving time and money compared to supplying by truck. And water was recycled by the ECOCLEAR, reducing the amount of water consumed on the project. So again, the customer he knew that trucking water was expensive. It often costs a lot of downtime, and they opted for that solution, having the equipment on hand. Again, here, this is where they performed pillar repair work also. So again, they were doing flat work, vertical work with the equipment, and recycling the water. So very versatile equipment to have on a job site. So in closing, I guess a great interest in hydrodemolition for road and bridge repair because of the many advantages including the safety and the productivity of the equipment. How to treat the blast water is a big question. You can use a third party or design your own system. You can also have the option to buy a water treatment system designed for this purpose. And this is what we offer at Aquajet. And it's been developed since 2017. So easy to transport, gives you flexibility. You can treat the water on your schedule. Again, flexibility. It's very safe for operators and the environment. It's efficient. It treats a lot of water, less reliant on water source, less water to manage overall. The return on investment of a OEM water treatment system is to us very high, considering that it costs about 25 times cheaper to treat the water with this equipment than it would to haul it to a third party. So considering the volumes of water that are used in hydrodemolition projects, in some cases, only one or two projects can help to pay for the equipment. So it makes sense if you're in the hydrodemolition business, or if you're a contractor and you're often requested to treat water on site. This is a great option for you to reduce your cost of operation and making your project safer for the environment. So I guess that's the end. If you have any questions, don't hesitate to contact Sean or I. And thank you for listening, and thank you for joining us. I'd like to thank Roads and Bridges for giving us the opportunity to talk about the hydrodemolition process and the different options available out there for contractors and customers to treat their water.
And thank you, Keith, too.
Thanks, Sean.
Yes, thank you to you both for that informative and resourceful presentation. We've now got time to respond to some questions from the audience. So I'll go through them one by one. And the first question that came through is, how do you contain water when working under a bridge or over the side, for example?
You want to do that one, Keith?
Yeah, I'll take that one. So, I mean, I understand that it's not always easy to contain the water. That's definitely a very good question. But contractors are very, very swift at finding options to do so. So in most cases, when we're looking at any repair work, the first way of looking at it is always to do it by hand, so manual removal. So that means that if it's under a bridge, for example, someone's going to have to set up scaffolding to prevent debris from falling, to have workers up there. So it wouldn't change for hydrodemolition. You would still have the same structure there, except for now we would basically tarp the area with plastic to be able to let the water flow over it into a low point that then pumped out of there and get it treated away from that structure. And we've been on several projects, and we've seen that being done that way, where people were able to channel and collect the water. Contractors are very, very good at creating these ways of capturing water. So they're very creative is the word I was looking for. John, you have something to add?
They're going to have to be dependent on the job that they're doing too, because sometimes it's a stream underneath, sometimes it's a road underneath, sometimes it could be a slope, which makes it more difficult. So if you've got a fairly flat spot underneath, then you just put down plastic and collect it with the sump pump, along with the debris. But yeah, it completely depends on the job itself. So it's hard question to answer with the easy answer.
Yeah. But in general, it's being done. So we can move on to the next one then, Brian.
Sure. Our next question is, exactly what information is included in the documentation, and how can that information be shared with stakeholders and government agencies in print, digital, or other means?
Yeah, okay. So I think this is the question about the water treatment system. It looks like the data logging system. So basically, the ECOCLEAR, as Sean pointed out during the presentation, has its own logging system. So it logs the amount of water that's going through the system, and at what levels of the pH level when it's being discharged is recorded, and also the turbidity of the water, or the TSS, total suspended solids amount, is being recorded. And this is registered. It can be down to lower than a minute, recorded every minute. And this information can be removed from the control system on a USB stick, then downloaded into an Excel file, where the numbers can be handed over to on an email to a project manager or DOT manager or the operating personnel on site.
Our next question is, are there any upgrades or optional equipment necessary if using the equipment with natural water sources such as rivers or ponds?
Yes and no. If typically water has to go into the high pressure pump. So normally going into the high pressure pump, water has to be filtered from 10 micron in some cases and ultra high down to 1 micron. So there could be some additional filtration required. But in regards to the ECOCLEAR itself, once that water is, if we're taking water from a river or lake, it should already be fairly clean. It can be put through with a simple filter, put through high pressure system, and again the ECOCLEAR will treat that water and bring it down to a natural level of pH and turbidity level where it could actually be discharged back into the lake or river source. I guess one thing point out, maybe no salt water on this for the equipment. That's mainly for the high pressure pump system. But other than maybe some additional filters, the equipment as it is fine to operate like that.
Okay. Our next question is, what's the minimum crew size for an operation employing all 3 machines on a bridge deck removal project?
I'll take this one. Typically, for operating a robot, you would have one operator that would be exclusive to the robot, and that's going to be that person's focus. The robot pretty much runs itself, but somebody has to watch it constantly. The other 2 components, which would be the water cleaning system, the ECOCLEAR, or the power pack, the ultra high pressure pump, either one of those do not need constant monitoring. They pretty much monitor themselves, and they're automated. The pump operator for the most part, at least in our machines, also runs the high pressure pump. I should say the robot operator also runs the high pressure pump. The ECOCLEAR is automated, so you don't need constant attention, but I would say every 45 minutes to an hour, walk over, take a look, see how the parameters are working, everything's within parameters. Like I said earlier, if this runs outside of its parameters, which can be set by the operator or the job site supervisor, then it will stop working. It will turn itself off and go into a safe mode. But and then the operator or the second operator will notice that the water level is coming up, and this is typically how you know this. But for the most part, it runs itself. The things that can shut it off would be you run out of CO2 or you run out of the chemicals.
So basically,
the answer to the question is, yeah, the minimum crew is 2.
Good.
Okay. Our next question is, can you explain in a little more detail how to set up a closed loop system with the AquaCutter and EcoClear? Does the water go directly from one to the other, or are holding tanks still necessary?
I'll answer this one as well. For the closed loop system on a hydrodemolition job, we'd have to have a source of water to start with. And that water is pumped from that source of water into the ultra high pressure pump, which from there to the robot where it does its work. It's drawn out from after it's been used with a trash pump into the EcoClear, and then from the EcoClear, it could go back into the power pack. But if that water starts getting warm above 40 degrees Celsius or close to 40 degrees Celsius or 138, 140 degrees Fahrenheit, then that water needs to be cooled. And the best way to cool it would be to send it into a second tank. So it would depend on how water is being used on the job. That would be the biggest determining factor, is the temperature of the water.
Yeah. And since the water flow coming into the EcoClear is not always constant, and going into the pump we would most likely recommend having a holding tank.
Okay, we've got time for one final question. I'm sorry?
No, I'm good. Okay.
Well, great. We've got time for just one final question then. Can you estimate the ROI of the EcoClear system?
Yeah, I always love these questions. Can I estimate the return on investment of an EcoClear? Not in time, because it's difficult, depends on a lot of projects. But as I mentioned previously, considering some of the costs that are involved with treating water on various projects that we've seen, for example, 15 cents a gallon to treat water. And if you consider that you can treat that water at a value that's 25 times cheaper, just on the operation costs, we're not considering the capital costs of the equipment, but only the treatment section of it. I mean, there's definitely some payoff money to be made there with this equipment, and not even considering how the benefits you'll have on your project. I mean, I'm just talking cost to treat water versus cost to treat water. But if you consider other factors like the mobility, how compact it is on site for you and your project, the amount of water that it can treat on demand, I think there should be a great return on investment. And most of our customers who own this equipment, for example, the AquaJet EcoClear, have been very successful in their business. So, and AquaJet developed this product to help their customers in need of a solution, because this was often handed over to general contractors. We get this all the time. General contractors coming in and say, well, I got to take care of the water. I don't know what to do. So their first call is they call the people that they know that do dewatering systems or systems that are way oversized for what we can do with compared to our hydrodemolition needs. So I think there's a good return on investment. I can't quantify the time, But if you calculate how much water you go through on a project, that'll give you some good numbers.
Well, terrific. Thank you again to you both. That wraps up the time for this webinar, and any questions we were unable to address will be answered offline. On behalf of Roads and Bridges Media and today's sponsor, AquaJet, I'd like to thank everyone for their participation. This webinar will soon be archived at the same URL that you used today, available on demand, as well as at www.roadsbridges.com. Stay well. Thanks again.